Hello, good afternoon students. How are you all? This is Suresh, Faculty of Chemistry from Infinity Learn. Welcome to Infinity Learn NCERT based NEET platform. How are you all? Great to see you guys. Okay, today's topic of interest is going to be solutions. So in this Infinity Learn YouTube channel, we are going to provide NCERT based NEET program, and in today's topic it is solutions. Before going for the details about this today's topic, I just want to give you what Infinity Learn is doing for the students who are preparing for NEET examinations. There you can see a double your score proven results with IT NEET droppers program, and there you can see it is a simple example what you can. Hi Kapilendra Pangi, good afternoon, happy to see you on the live. Okay, so for students are seen for the just basis to motivate you guys. Ashrita, Akhil Verma, Hemadyuti, Satyanarayan, they got just 300 odd marks in 2023. Aaron, ये डिटेल्ड वीडियो होगा, ये स्टे ट्यून्ड है ना. एंड इसमें दे एनरोल फॉर सब couple of courses in the NEET exam preparation for Infinity Learn. They just see the score more than double they got it. 310 becomes 661 है ना, 313 becomes 658, 330 becomes 650 and 310 becomes 652. कितना मार्क बढ़ा का 351 बढ़ गया आश्रिता का, एंड अखिल वर्मा 341 मार्क्स बढ़ गया. सचिन मौर्य, इट इज़ फॉर नीट एग्जामिनेशन बेटा. अर्पित पांडे, गुड आफ्टरनून, एंड हेमाद्युति 342 एंड सत्यनारायण 320 मार्क्स इन लोग को बढ़ गया. सो आई जस्ट वांट टू से many more students are achieving their medical dreams, and you will be the next for the next 2025 preparation में है ना. कपिलेंद्र, good afternoon, good afternoon. Arpit Pandey, good afternoon. Sachin Maurya, good afternoon. Okay, Aaron, right. So what I want to say, crack your NEET examination. For that simply you can just like, share and subscribe these YouTube videos so that your friends and for you are going to be benefited. And आपके लिए ACO test preparation with Infinity Learn, you can have Infinity Learn test prep application is there. It is not for CBSE board. ये NCERT बेस्ड सोल्यूशन जो आपको अभी इसी वक्त में दे रहा है ना, ये CBSE को भी उठाएंगे. फ़ायदा उठाने की कोशिश करो बेटा. एडवांटेजेस फॉर द बोर्ड्स एज वेल एज फोकस ऑन ऑब्जेक्टिव टाइप मोर. यस, बिल्कुल, यस. ओके Aaron, right. So you have live classes, mock test, create your own test, and आपका भी 24/7 doubt resolutions भी होगा. And also you can see we are on the social platforms like Infinity Learn. You have YouTube channel, we have Instagram, Facebook and Telegram. You have Infinity Learn Meta app, you can download, it is there in the description, link भी है. And also first AI driven program. So आर्टिफिशियल इंटेलिजेंस आजकल बहुत खास बात है. आपका एजुकेशन इंडस्ट्री में आर्टिफिशियल इंटेलिजेंस इंट्रोड्यूस किया हमारा इन्फिनिटी लर्न है. सो विदाउट लेट अस स्टार्ट टुडे एस ऑफ टॉपिक. Today's topic of interest is going to be solutions and colligative properties. Stay tuned my dear students. These solutions and colligative properties important, and it is for CBSE examination as well as CBSE बोर्ड को भी फ़ायदा उठाने की कोशिश करो, फिर भी नीट एग्जामिनेशन को भी आपका हर कॉन्सेप्ट का डिटेल्ड वर्जन में एक ही सेशन में आपका देना चाहता हूँ. गेट रेडी. एरन, सचिन, Aimal Hussain, good afternoon. Kapilendra, Arpit Pandey, Sachin Maurya, everybody. Yes, Sri Chaitanya offline student came for revision. Yes, it is for kind of revision. एक ही सेशन में पूरा सारे के सारे solutions revision आपके सामने है ना बेटा. And we have the various topics, types of solutions and methods of expression, concentration terms is for. Yes, Hussain, it's correct. What you felt it is for you also. and also you have vapor pressure and Raoult's law, colligative properties, abnormal molecular mass. These are the these are the various topics that we are going to discuss. And if you get a question, definitely you are going to get a question from colligative properties and abnormal molecular masses. Abnormal molecular masses, there we are going to discuss about the Van 't Hoff factor. Yes, get ready for that. We just talk about methods of expression, concentration terms, and also includes concept, formulas, and nearly 3 o'clock, Sachin Maurya. Okay, stay tuned. Before 3 o'clock, I am going to end up this, right? Okay. And Van 't Hoff factor and types of solutions. We have the component. What is a solution? Solution is nothing but combination of two homogeneous components. Here a solute plus solvent gives rise solution. So the types of solution is based on the physical state of the solvent. The one which is present in the less number of moles is called solute. The one which is present in the larger moles of solution is called solvent. Here a binary solution contains only two components, solvent A and solute B, and also solvent determine the physical state at which the solution is formed. And also based on the physical state we can have solid solutions, liquid solutions, and gaseous solutions. That is there in the tabular form in the NCERT textbook, and you will be having a question, simple multiple type questions like the types of solutions. You have gaseous solution, gas combination में हो सकते हैं, liquid gas combination में हो सकते हैं, solid gas combination भी हो सकते हैं. उसमें gaseous solution में solvent सारा के सारा gases होना चाहिए, and gas mixture of oxygen and nitrogen. Your air is an example, liquid and gas, chloroform mixed in nitrogen gas. Chloroform is evaporated, so chloroform is liquid, है ना? And the solid gas, camphor in the nitrogen gas, camphor is sublimated, solid in gas. Similarly, liquid solutions में you are going to say liquid is going to be the solvent. You can say gas, liquid, solid, liquid, gas, liquid, carbonated water, soda, and gas, liquid, you can say ethyl alcohol and water, and also solid liquid, chini, water, sugar, water, salt, water. Are I getting or not? And also solid types of solutions, solid, and gas, solid, and liquid solutions. These are the corresponding example. इसमें आपका multiple choice का questions कैसे आ सकते हैं? Which of the following is an example for a gas liquid solution? Like that, typical examples can be given. You can do it better. And also aqueous and non-aqueous solutions. A solution in which the solvent is an aqueous means water, and non-aqueous means not other than water. And also alcoholic solution is also called as alcoholic salt. Non-aqueous solutions have benzene, chloroform, ether, and carbon disulfide, carbon tetrachloride are the best example for the non-aqueous solutions. And also let us talk about the concentration terms. Let us discuss about the concentration terms. So how much solute is present in a given amount of the solution is called as a concentration. And methods of expression concentration terms, you have weight percent or mass percent. It is percent. So for that you need to give for the 100 for 100. So weight percent is going to be the weight in grams of solute present in 100 grams of solute. That is equal. This is the formula. Everybody get ready with your pen and paper so that we can write the formulas and make a cheat sheet. That could be helpful for your preparation. And also when you just go into the examination hall, before that moment आप एक बार रिवाइज करने का कोशिश कर सकते हैं कि ना, जल्दी फायदा उठाने की कोशिश करो. And you just write weight percentage is equal to weight of solute upon weight of solution into 100. Also weight volume percentage is that is equal to weight of solute upon volume of the solution into 100. This is what you call it as W by V, and this is your formula. Get ready to note down this formula. फटाफट एक ही सेशन में सारे के सारे सॉल्यूशंस सिर्फ आपके सामने मैं एक बार रिवाइज करना चाहता हूँ. वॉल्यूम परसेंट, so I mean to say the amount of the solution in volume of the solute upon volume of the solution into 100. So these are the various formulas that are required to calculate for the volume percentage, mass percentage and weight percentages, weight and weight volume and volume. And also you can say molarity. It's a perfect one. Molarity is the number of moles of solute present in a liter of solution. That is what you call it as molarity, and it is given as number of moles upon volume in liters. And also you can say molarity is equal to weight by gram molecular weight and into 1000 by V in milliliter. Hope you understand. Sachin Maurya, K. Hussain, Kapilendra Pangi, Arpit Pandey, Aaron, Amil Hussain. Okay, so here weight is W and gram molecular weight V is the volume in expression in milliliters. अगर आपको कुछ डाउट है ना तो चार्ट बॉक्स में थोड़ा आप पूछ सकते हैं. And it is a live interactive session and you don't have to worry. So सर को कैसे डाउट पूछना कैसे करके. Okay, and also you can take some useful relations. Number of millimoles of the solute present. अगर मान लो वॉल्यूम मिलीलीटर में दे सकते हैं तो number of millimoles is equal to mv. And also you can say number of moles, that is equal to mv upon 1000 if it is in the milliliters. And also number of moles volume, अगर volume liter में देने तो mv is going to be the correct one. And also you can say when a solution is diluted the molarity decreases and the number of moles of solute before and after dilution remains constant. mv हमेशा constant होगा, तभी आपका molarity dilution में m1 dilution law का हिसाब से m1 v1 is equal to m2 v2. So m1 v1 are the molarity and the volume before dilution, m2 v2 are the molarity and volume after dilution. Are you getting or not? Clear? Yes. Now if the volume of water is added during the dilution, how much volume should be added? So that is going to be v2 minus v1. So that m1 v1 upon m2 minus v1 you can say, or m1 minus m2 of v1 by m1 you can also say. It's a simple trick that you can use it for the dilution and the mixing, and it is an outstanding formulas. You can make it and you can grab your medical seat. So if you study like this, you are going to guarantee you that the preparation is going to be awesome, my dear children. And also methods of concentration और एक चीज़ है molarity, and that we already discussed, and the relation between the molarity and the density, and it is going to be molarity is equal to 10 into weight volume percentage upon gram molecular weight. And also you can get molarity is equal to density weight percentage into 10 upon gram molecular weight. So these are the various formulas that we are going to see, है ना. Amil Hussain, following this for relations, any doubt? Sachin Maurya. So let's see methods of concentration when it is mixed, when it is diluted. We know that for diluted, dilution law के हिसाब से m1 v1 is equal to m2 v2 होगा. अगर लेकिन ये दो सॉल्यूशंस मिक्स करने तो m1 v1 plus m2 v2 upon v1 plus v2. Yes, all clear. That's good. Please stay connected in the chat box so that we can have a discussion. And when two solutions are titrated against each other, their Rudrakshi high, when a solution is mixed with another solution, allow them to react, it is going to be m1 v1 upon n1 is equal to m2 v2 upon N2, where N1 and N2 are the N factors and these numbers used in the balancing of the chemical reactions N1 and N2 है ना. Rudrakshi, how are you? And moving ahead, normality. Normality is the number of gram equivalents, just like a molarity. Normality is the number of gram equivalents of the solute present in a liter of the solution. That is what you call it as normality. In this normality, it is again temperature independent. Molarity is temperature dependent and normality is temperature dependent. दोनों depend करते हैं. And normality and molarity interrelation, I have a super thing, and normality is equal to molarity into n factor. What is this n factor? This is a very important. So normality is equal to molarity, n factor क्या होगा? इसका number of H plus ions that can be given by 1 mole of the acid or 1 molecule of the acid. Rudrakshi, is my voice is low? Is my voice is audible, Sachin? Please confirm, is my voice is audible? Is my voice is audible? Anybody in the class? Is my voice is audible? Hello? So let's go ahead for the bases. Normality is equal to molarity into acidity of the base. Molarity is equal to acidity of the base. Acidity of the base is number of OH minus. Yes, is yeah. Thank you very much for your response. Acidity of the base is number of OH minus that I am given by a molecule of the base, and also it can be calculated for the salt, and for the salt normality is equal to molarity is into total number of units, either magnitude of the positive charge. अभी ठीक है, वेरी गुड. पॉजिटिव चार्ज, मैग्नीट्यूड ऑफ द पॉजिटिव चार्ज है और मैग्नीट्यूड ऑफ द नेगेटिव चार्ज होगा. सो ईदर दिस और दैट यू कैन टेक. अगर आपका रेडॉक्स चेंज होगा तो एन फैक्टर आपका मिलेगा नंबर ऑफ इलेक्ट्रॉन्स दैट आर इन्वॉल्व्ड इन द रेडॉक्स चेंज. ओके, वेरी गुड, नो प्रॉब्लम. यस, नाउ आई वांट टू से मोलालिटी और एक चीज है. मोलालिटी इज द नंबर ऑफ मोल्स ऑफ सोल्यूट प्रेजेंट इन ए kg ऑफ सॉल्वेंट, एंड हियर दिस इज योर फॉर्मूला वेयर इट इज टेम्परेचर इंडिपेंडेंट. टेम्परेचर इंडिपेंडेंट, ठीक है. एंड you can say molarity and molality and normality, and many person you can say molality and mole fraction only are temperature independent because उसमें volume नहीं है and you have mass over here, है ना बेटा. That's good. Let's see methods of concentration. Parts per million. अरे parts percent is for 100, per million it is 10 raised 6. Yes, Rudrakshi, it is temperature independent, it is for molality, and ppm is equal to weight of the solute upon weight of the solution, you can say, into 10 raised 6. So per million कितना, million means it is going to be 10 per 6 का होगा, है ना. And also mole fraction, it is the ratio of number of moles of a component to the total number of all components. It is what you call it as a mole fraction. मान लो mole fraction फिर भी a temperature independent होगा. Temperature independent, है ना. And in this I just want to say mole fraction of component B, that is equal to mole fraction of B is equal to NB by Na plus NB. अगर mole fraction of A and mole fraction of B is equal to 1, and this helps a lot, ठीक है. And many more things we need to discuss. Let us talk about the sum of the mole fraction for all components for a binary solution और ternary solution, जो भी solution होगा ये आपका unity का बराबर होना चाहिए. And also on 100 moles, the mole fraction and the mole percentage have no units because they are fraction, they are relative terms, so that they cannot have any unit for that. Okay. And also solubility, we just discussed about the solubility for the Henry's law. In this solubility for the Henry's law, solubility of a gas, yes, Rudrakshi, what you said is correct. Solubility of a gas is explained on the basis of effect of pressure that is given by Henry's law. So, effect of pressure. When a solute gas is taken, good afternoon Radhika, what's good afternoon, and when the gas is exerting a pressure, and if you increase the pressure, gas is going to be more soluble. This is your gas, this is your liquid. When the pressure is increased by down its piston, what happen? More amount of the gas is entering into the solution. That is what we call it as pressure increases, solubility of the gas increases. That's what I just want to say. Pressure of the gas increases, the solubility of the Rudrakshi and Radhika, you please focus here. And I just want to say pressure of the gas is directly proportional to mole fraction of the gas. Mole fraction of the gas is the function of the solubility. And when the class is going on, I am going to give you the most important points in a simplest way based on NCERT line by line. I am just going to explore everything, and I want to give you the inputs in such a way that you are going to get a seat guarantee program. Yes, Rudrakshi, please focus. No personal discussions, no personal chattings. Okay, that is given as pressure of the gas is equal to Henry's law constant and mole fraction of the gas. मैं क्या बोलना चाहता हूँ, if you talk about pressure of the gas and mole fraction of the gas, it is going to be like this. A straight line passes through the origin, है ना? And also you can see this, अगर KH is called Henry's law constant. ये Henry's law constant क्या बोल सकते हैं आपका? Henry's law constant is going to be the slope, and NEET एग्जामिनेशन में ये ग्राफ का हिसाब से आपका एक क्वेश्चन मिलने का एक संभावना भी है. And for a pressure of the gas, here it is said that the pressure of the gas is directly proportional to mole fraction of the gas, and the pressure of the gas is equal to Henry's law constant and mole fraction of the gas. उसमें Henry's law constant is a constant. हर गैस का KH अलग अलग होता है. Yes, it is Sachin Maurya, you said is correct. Yeah, and every gas will have different KH values at different temperatures, and this is going to be constant at a given temperature. As temperature increases, solubility decreases. For a gas, yes, KH value increases, solubility decreases. Okay, and also you can say Henry's law constant ka different implications. Yes, any doubt Sachin Maurya? अगर कुछ डाउट होगा तो रुद्राक्षी and Radhika, you can ask me. Yes, okay. Now also say solubility, values of Henry's law constant आपका पता चलेगा. जिस गैस का Henry's constant बहुत कम है वो गैस ज़्यादा soluble होगा. Yes, that's correct. And also limitations for the Henry's law. This Henry's law is only limited. मैं पहले से बोल रहा था NCERT से आपका ये टॉपिक CBSE एग्जामिनेशन को फ़ायदा उठाने का कोशिश करो, एंड फिर भी सीधा पैरेलली आपका नीट एग्जामिनेशन को भी आपका फ़ायदा पक्का होगा, है ना. And the temperature and the pressure should not be too low, pressure should not be too high, and the gas should not react with the solution or the solvent. Okay, and also evaporation. When evaporation, what is the meaning of the vapor pressure? When the liquid is converted into vapor and the vapor molecule again come and make a collision on the liquid surface, ताकि इसका सरफेस का ऊपर कुछ प्रेशर लग जाएगा. ये प्रेशर इक्विलिब्रियम स्टेट में आपका इक्विलिब्रियम वेपर प्रेशर बोलना है, एंड दिस इज व्हाट यू कॉल इट इज नॉर्मली द वेपर प्रेशर. And the pressure exerted by the liquid on its own solution at the state of equilibrium at a given temperature is called as vapor pressure. And the factors, vapor pressure is dependent nature of the liquid and the temperature. And how do you say this nature of a liquid? And this nature of a liquid is जिस liquid में intermolecular force of attractions कम होगा, इसका रेट ऑफ वेपराइजेशन ज़्यादा होगा, वेपर प्रेशर ज़्यादा होगा. दैट्स गुड. अगर टेम्परेचर काइनेटिक एनर्जी इज डायरेक्टली प्रोपोर्शनल टू एब्सोल्यूट टेम्परेचर, ताकि काइनेटिक एनर्जी ज़्यादा होगा. अगर टेम्परेचर बढ़ जाएगा, काइनेटिक एनर्जी बढ़ जाएगा, काइनेटिक एनर्जी बढ़ जाएगा तो कोलिशंस बढ़ जाएगा, प्रेशर भी बढ़ जाएगा. अगर टेम्परेचर बढ़ जाएगा तो काइनेटिक एनर्जी बढ़ जाएगा एंड वेपर प्रेशर बढ़ जाएगा. सिंपल ट्रिक्स एनसीईआरटी लाइन बाय लाइन आपका मिल रहे हैं, है ना. एंड आल्सो volatile and non-volatile liquids, we are going to discuss about the vapor pressure and the temperature. With the increase in temperature, vapor pressure in liquid increases exponentially. That is given as Clausius-Clapeyron equation, जिसमें इथाइल ईथर में IMF इंटरमोलिकुलर फोर्स बहुत कम है, एंड इट इज गोइंग टू बी लाइक दिस. एंड यू कैन से वाटर में हाइड्रोजन बॉन्डिंग है, सो दैट वेपर प्रेशर कम होगा. सो लाइक दैट इट इज इंक्रीजेस एक्सपोनेंशियली एज द टेम्परेचर इंक्रीजेस. यस, inversely proportional to vapor pressure with these intermolecular forces. Sachin Maurya, you're very good. लाइट चले गई थी रुद्राक्षी, आई एम वेटिंग फॉर योर रिस्पॉन्स. ओके, एंड इट इज वेरी वेरी इंपॉर्टेंट Clausius-Clapeyron equation, and it is given as vapor pressure, and this is your log P and temperature. So you are going to get a straight line with a negative slope is going to be delta H vapor, enthalpy of evaporation upon 2.303 R. So this kind of graphs are important for NEET examination, and you have to maintain that. Okay, this is about the vapor pressure and the temperature, and the boiling point, the temperature at which the liquid vapor pressure is equal to its atmospheric pressure. मैं क्या बोलना चाहता हूँ यहाँ पर, you can say the vapor pressure, this is your vapor pressure and the temperature. So as temperature increases, vapor pressure increases. जब आपका वेपर प्रेशर आपका 1 atm बन जाएगा, this is 1 atm, so that 1 atm, that is the temperature, that is what you call it as the boiling point temperature. If you add little bit of solute in it, its boiling point is going to be increased. Why? Because its vapor pressure is decreased. Okay, I just want to say vapor pressure of the liquid solution, that is explained by your Raoult's law. I want to say the vapor pressure of the liquid component PA is directly proportional to mole fraction of A. I just want to say PA is equal to P naught A mole fraction of A. So like that the components will be given, and based on that we are going to see all kinds of intermolecular force related solutions. There you can see the Raoult's law, positive deviation, negative deviation, everything. Temperature increases and versus vapor, pressure also increases. Rudrakshi, what you said is correct. ठीक है, एक मिनट. Yeah, moving ahead. Yes, Rudrakshi, what you said is correct. Raoult's law is theoretical value or experimental. Raoult's law is experimentally verified theory. है ना? Session. It is experimentally verified. And also, what is Raoult's law? Raoult's law says PA is directly proportional to P naught A and mole fraction of A. So, what is this P naught A? PA? Vapor pressure of liquid component, partial vapor pressure of liquid component A and mole fraction of A in the liquid mixture. P naught A is the vapor pressure of the pure liquid A and PB is equal to mole fraction of B and P naught B. है ना? Similarly, according to Dalton's law, P total is equal to PA plus PB. So, I mean to say PA plus PB. I mean to say PA is equal to this much, PB is equal to this much. I just want to say P naught A mole fraction of A, P naught B mole fraction of B, and also P total is equal to 1 minus mole fraction, 1 plus mole fraction of B, P naught A plus mole fraction of B, P naught B, and you can also say P total is equal to P naught B minus P naught A of mole fraction of A plus P naught B. Yes, this Raoult's law is experimentally verified. I just want to say this is the experimental verification. A solution which obeys this graph is said to be an ideal solution. Ideal solution आपका होगा जो solution हर concentration range में ये Raoult law obey करते जाएगी. जैसे solution ideal solution मानना है. Ideal solution में क्या क्या चीज़ होगा? Intermolecular force ठीक होगा. There is an intermolecular force do not change. I mean to say A is interacting with A and B is interacting with B and A is interacting with B. So, this is before mixing and this is after mixing. The magnitude of the intermolecular forces before mixing should equal to after mixing, and it is going to be PA is equal to P naught A mole fraction of A, PB is equal to P naught B mole fraction of B, and it is going to be TT is equal to P naught A plus P naught B, जिसमें आपका enthalpy of mixing is going to be 0 and enthalpy of the solution is going to be 0, and this is what you call it as, this is what you call it, any solution which obeys this is what you call it as an ideal solution. Ideal solution. आपका बहुत सारे examples भी है. I just want to say the examples for that is going to be, so ideal solution उसमें enthalpy of mixing is 0, enthalpy of solution mixing is going to be 0, change in the volume is also going to be 0. Ideal solution will satisfy this condition and this condition, and intermolecular forces are going to be the same. And for example, 50 centimeter cube of benzene, 50 milliliters of benzene, 50 milliliters of toluene, the volume of the solution exactly 100 milliliters. So, enthalpy of mixing is going to be 0. Like that you need to say various examples: benzene and toluene, N-hexane and heptane, ethyl bromide, ethyl chloride, chlorobenzene and bromobenzene, various types of solutions that can be given. And also you can say non-ideal solution, उसमें enthalpy of mixing बिल्कुल नहीं 0 होगा, it can be greater than 0, it can be less than 0. Enthalpy of solution B, it can be greater than 0, it can be less than 0. And I just want to say non-ideal solution showing a positive deviation, जैसे पॉजिटिव डिविएशन करने के लिए इंटरमॉलिक्यूलर फोर्सेस मिक्सिंग प्रोसेस में आपका कम होना चाहिए, जिसका कारण में वेपर प्रेशर बढ़ना चाहिए, सो दैट यू कैन से अगर वेपर प्रेशर आइडियल सॉल्यूशन मान लो तो ऐसे होगा एंड वेपर प्रेशर बढ़ रहे हैं, क्योंकि वेपर प्रेशर बढ़ रहा है इंटरमॉलिक्यूलर फोर्स मिक्सिंग में कमी आ रहे हैं, and also you can say and Pa is greater than P naught A mole fraction of A, Pb is greater than P naught B mole fraction of B, and also for then enthalpy of mixing is going to be positive and change in the volume is going to be positive, right? And you can see examples acetone and carbon disulfide and acetone ethyl alcohol, acetone and benzene, methyl alcohol and water. क्या होगा ये मिथाइल अल्कोहल एंड वाटर, ये मिथाइल अल्कोहल जो मिथाइल ग्रुप है ना, ये वाटर में हाइड्रोजन बॉन्ड है ना, जो ये मिथाइल ग्रुप वाटर में हाइड्रोजन बॉन्ड को डिसरप्ट कर रहे हैं, ताकि आपका इंटरमॉलिक्यूलर फोर्सेस कमी आ रहे हैं डिसोल्यूशन के बाद, सो दैट वेपर प्रेशर बढ़ रहा है. That is the way you need to talk. So every point I am going to explain about the vapor pressure and every point from the NCERT textbook line by line हमारा YouTube channel में Infinity Learn Studio से. So please like, share and subscribe this so that आपका भी फायदा होगा, आपका फ्रेंड्स को भी फायदा होगा, है ना बेटा? सचिन, रुद्राक्षी, सचिन, एनी डाउट? राधिका, ओके, आगे बढ़ना. सो एग्जाम्पल इथाइल अल्कोहल एंड वाटर, कार्बन टेट्राक्लोराइड, क्लोरोफॉर्म, बेंजीन एंड कार्बन टेट्राक्लोराइड, कार्बन टेट्राक्लोराइड, टोलिन, and so many examples you can say. Non-ideal solutions having negative deviation. Negative deviation में आपका वेपर प्रेशर कम आ रहा है, क्योंकि इंटरमॉलिक्यूलर फोर्स बढ़ रहा है, वेपर प्रेशर इज डिक्रीजिंग. कैसे? आपका जो एग्जाम्पल है एसीटोन एंड क्लोरोफॉर्म, neither chloroform nor acetone form intermolecular hydrogen bonding, but when they mix na, they start new type of intermolecular forces. Intermolecular hydrogen bonding is formed. Intermolecular hydrogen bonds means intermolecular force बढ़ रहे हैं, so that vapor pressure decreased. So the vapor pressure is decreased. It is supposed to be like this, and its vapor pressure is decreased. Okay, and I want to say it is example enthalpy of mixing is negative. Dear children, every point हमारा YouTube channel में NCERT textbooks भी cover कर रहे हैं. So please don't leave these sessions and stay tuned and get advantage of this. My dear students, here enthalpy of mixing negative होना चाहिए. So new bonds are formed, therefore energy is released. So it is going to be little exothermic process. Example chloroform benzene, chloroform diethyl ether, acetone and aniline. We discussed chloroform and acetone are the various examples that you can see, my dear students. And also azeotropic mixture. Azeotropic mixtures are actually non-ideal solution which boil together in a particular composition. And I just want to give you a small trick here. जो नॉन आइडियल सॉल्यूशन, जो सॉल्यूशन आपका राउल्ट लॉ से पॉजिटिव डेविएशन कर रहे हैं, दैट इज कॉल्ड मिनिमम बॉइलिंग एजियोट्रोप. जो सॉल्यूशन राउल्ट लॉ से पॉजिटिव डेविएशन कर रहे हैं, नेगेटिव बॉइलिंग एजियोट्रोप, मिनिमम बॉइलिंग एजियोट्रोप एंड मैक्सिमम बॉइलिंग एजियोट्रोप, दैट इज व्हाट इट इज गिवन हियर. एंड slowly we can go into the colligative properties and colligative properties. Yeah, talking about the properties of the solutions, which depends on the number of solute particles with respect to of their chemical nature, are called colligative properties. एंड ये colligative properties है, and these colligative properties are only applicable for non-volatile solute containing solutions, right? And also the solution supposed to be very dilute, and the solution is theoretically assumed to be ideal, right? So there are 4 colligative properties. एक है relative lowering of vapor pressure, so RLVP बोलना है वाला, and elevation in boiling point, depression in freezing point, and osmotic pressure भी है ना? And also we are going to discuss about each and everything about the colligative properties, and let's talk about this relative lowering of vapor pressure. When a non-volatile solute is added, the solution vapor pressure is decreased, that is called lowering of vapor pressure, with related to its pure solvent, that is what you call it as a relative lowering of vapor pressure, that is given as relative lowering of vapor pressure is given as P naught minus Ps upon P naught is equal to mole fraction of the solute. So you can use this direct relation to crack the numericals. Are some Rudrakshi, Sachin, and you all tell me just for the same simple NCERT based question. अरे कॉलिगेटिव प्रॉपर्टीज किस चीज़ के लिए हम ही इस्तेमाल कर सकते हैं? जो कॉलिगेटिव प्रॉपर्टी है हम मॉलिक्यूलर मास कैलकुलेट करने के लिए इस्तेमाल कर सकते हैं. ओके, यहाँ से कैसे कैलकुलेट कर सकते हैं? अरे सिंपल बेटा, देखो मोल फ्रैक्शन मीन्स पी नॉट माइनस पी एस अपॉन पी नॉट इज इक्वल टू एन बी एंड अपॉन एन ए प्लस एन बी. If the solute is so diluted, this can be ignored and you can say P naught minus Ps upon P naught is equal to Nb upon Na. So from there you can also say the simple trick I can give you, mind it, simple trick I can give you, P naught minus Ps upon Ps is equal to Nb upon Na. You please use this formula to calculate molecular weight for the NEET examinations. This is modified by taking the inverse one, and I don't want to derive this. And also elevation in the boiling point. What is the meaning of the boiling point? Boiling point is the temperature at which the solution's vapor pressure is exactly equal to the vapor pressure, exactly equal to the atmospheric pressure. You can say this is your, I just want to write it here instead of this is your vapor pressure and this is your temperature. This is the solvent. If a non-volatile solute is added, the vapor pressure of the solution is going to be less than that, it is going to be solution. And मान लो ये वाला 1 ATM का है और 1 bar. This is the temperature, you can say. This is the temperature is what you call it as a T naught B. This is the temperature, you can say TBS, and between these two what you call it as delta TB, delta TB. Okay, and I want to say this elevation in boiling point delta TB is equal to TBS minus TB naught, boiling point of the solution, boiling point of the pure solvent. Are you getting or not clear? Fine, Maurya. How? And also I just want to say delta TB is directly proportional to molality, and delta TB is equal to Kb into molality. Molality. This is what you can say. This is ebullioscopic constant, molar elevation constant or ebullioscopic constant. ठीक है? Right. And also What is this ubilioscopic constant? And this ubilioscopic constant is the one is said to be mRTB square upon 1000 into enthalpy of evaporation. This is thermodynamically given ubilioscopic constant or molar elevation constant. It is the constant for a solvent. It is equal to the elevation in boiling point happens when 1 mole of the solute is dissolved in 1 kg of the solvent. That definition is very, very important. Every line in the NCERT you can cross check it, it is being covered in today's class, right. So, Sachin Maurya, all clear? Sachin Maurya, all clear? And also you can say depression in freezing point. If you add some solute, in the solution, its freezing point is going to be decreased. That is what you call it as a depression in freezing point. And this is the solvent, and solvent का freezing point है, and this is the solution का freezing point है, and you can say delta TF is equal to T naught F minus T naught S, the freezing point of the solution, and delta TF is directly proportional to molality, and delta TF is equal to Kf into molality. What is this Kf? What is this Kf? Kf is cryoscopic constant or molar depression constant. From here is also you can calculate the molecular mass. It is given as RT naught F square into 1000 into enthalpy of freezing. Clear? And you also say osmotic pressure. What is the meaning of osmotic pressure? When this is your semi-permeable membrane, a solution C1, a solution C2, let us say C2 concentration is greater than C1, and when two solutions are separated by a semi-permeable membrane and the concentration, the solvent migrate from low concentration to high concentration across the semi-permeable membrane. That process is what you call it as osmosis. To resist the inflow of the solvent from the higher concentration side, the opposing force is being applied. That is what you call it as osmotic pressure, right? Henam. And in that osmotic pressure, you can discuss this osmotic pressure in different ways. According to Hoff equation, yes, PV is equal to nRT, that is for ideal gases. What Hoff felt, for an ideal solution it behaves like an ideal gas, so that pi V is equal to nRT you want to take. From that, pi is what you can say it is osmotic pressure, that is given as pi is equal to CRT. C is the concentration, R is the gas law, and gas constant, T is the temperature. Okay, from there you can say reverse osmosis. In the reverse osmosis, we can get the pure water from the sea water. The condition for the reverse osmosis, fresh water and salt water, actual osmosis takes place in this direction. When the piston is applied over here, when the pressure exerted is greater than the osmotic pressure, taki then only the solvent migrate from the high concentration to low concentration, then it is going to get the water in this way. So, this process is said to be reverse osmosis. So, for what we are learning these colligative properties. We are learning these colligative properties for the sake of calculating the molecular masses. When you want to calculate the molecular masses, because when you have to make a solution, the solvent and solute, the solute is dissolved in the solvents, what happen? Maybe association or dissociation takes place. Because of the association, dissociation, number of molecules are going to be changed. As the number of molecules are changing, it changes its value for the molecular mass. Let us say when you talk about sodium chloride, it is dissociating, it gives a sodium plus and Cl minus dissociation. You want to say association CH3 and C double bond OH and CH3 C double bond O and OH. So that there is an intermolecular hydrogen bonding dimerization takes place, so that number of molecules are decreasing due to association. This is what you call it as dissociation, this is what you call it as association. Mind it, this acetic acid or the carboxylic acids, when you dissolve in the water, they dissociate. When you dissolve in the aqueous, non-aqueous solution, they are going to be associate. Okay, that's also very important parameter. And the Van 't Hoff factor is the ratio of observed colligative property and calculated colligative property. Observed colligative property and calculated colligative property. And this Van 't Hoff factor I can be the ratio of normal molecular mass upon abnormal molecular mass, or the ratio of calculated molar mass or observed molar mass, and the total number of moles of particles upon number of moles of the particles. So you can calculate Van 't Hoff factor in a various ways. Of course, how to take the degree of ionization and Van 't Hoff factor into the consideration. For degree of ionization, alpha is equal to I minus 1 by n minus 1 for dissociation into n number of particles. N number of particles. That's very, very important and the simplest trick that you can have. For dissociation, for association, it is going to be alpha is equal to I minus 1 upon 1 by n minus 1, where n is equal to dimerization. N is equal to 2, trimerization. N is equal to 3, tetramerization. That is equal to n is equal to 4. है ना? So that is very important. And also say relative lowering of vapor pressure, corrected Van 't Hoff factors, corrected colligative properties with respect to Van 't Hoff factor. हर colligative property का I से multiply करो. So P naught minus Ps upon P naught is equal to I into mole fraction of the solute. And also depression in freezing point, delta Tf is equal to IKF into M. M stands for molality Maurya. And also elevation in boiling point, delta Tb is equal to IKB into molality. And osmotic pressure pi is equal to ICST. So our colligative properties I से multiply करना है ना बेटा, clear? And also say in case of dissociation I value always greater than 1. In case of association I value is less than 1. If there is an no association and dissociation, I value is going to be 1. And I just want to give you a simple trick to apply this colligative property. So हर क्लास में सुरेश सर का एक ट्रिक मिलेगा, है ना? I just want to say, मान लो अगर इंटरमॉलिक्यूलर फोर्सेस बढ़ते जाएगा, वेपर प्रेशर बढ़ते जाएगा, कम होना, इंटरमॉलिक्यूलर फोर्सेस increases, vapor pressure decreases. That's very important. Okay, and also every colligative property is related to the vapor pressure. That is one more important parameter. I just want to say, as number of particles increases, I value increases. Yes, that's very important. As I value increases, what will happen? boiling point increases. As I value increases, you are going to increase its osmotic pressure. As I value increases, it is going to decrease vapor pressure. As I value increases, it is going to decrease the freezing point. काम बहुत बहुत important चीज़ है, बहुत बहुत important चीज़ है ना? And I just want to give you a simple trick, simple question मैं खुद बना के रख दिया आपको. And before going for the closure of the session, stay tuned. Okay, so let us say glucose and sodium chloride and magnesium chloride and aluminium chloride. These three are given. I just want to take the vapor pressures and the boiling point and freezing point, everything into the consideration, where you let us talk about their respect to I value. I value is going to be 1. Kyunki glucose is a non-electrolyte, it do not ionize. Whereas you can see sodium chloride ये dissociate कर जाएगा. Assume there is a 100% dissociation. मान लो ये वाला 100% dissociation का तरीका दिया, and it is going to be NaCl I value is 2 and MgCl I value is 3 and it is going to be I value is going to be 4. जब I value बढ़ते जाएगा ना, आपका बॉइलिंग पॉइंट का ऑर्डर क्या होगा, फ्रीजिंग पॉइंट का क्या होगा, एंड ऑस्मोटिक प्रेशर का क्या होगा, वेपर प्रेशर का क्या होगा. एंड आई जस्ट वांट टू से बॉइलिंग पॉइंट एज आई वैल्यू इंक्रीजेस आपका बॉइलिंग पॉइंट मिलेगी. ग्लूकोज एंड NaCl MgCl2 AlCl3. So glucose less as number of particles increases in this way. Similarly, आपका osmotic pressure भी glucose NaCl MgCl2 and AlCl3. And also I just want to say vapor pressure and freezing point का reverse होगा. freezing point and vapor pressure glucose less than NaCl MgCl2 and AlCl3. फिर भी अगर glucose NaCl MgCl2 and AlCl3, like that, it is the simplest version that you can have a beautiful questions from the NCERT, and you can see various points from the NCERT textbook in the exam and exemplar questions also. You can see in the in-text questions, and you can see the same model of the questions in the NEET examination. It has been asked in the previous NEET examination as well as in CBSE examination, and in 2025 you follow the simple method, you will understand, and this is the trick given by me for you guys so that you can really enjoy it. Hope you understand today's class. We discussed about the solutions, सारे के सारे one shot revision program, and every point from the NCERT line by line clear कर चुका. Hope you like this. एक चार्ट में, एक कमेंट बॉक्स में आपका थोड़ा सा रेस्पॉन्स दे, एक फायर इमोजी है, थम्स अप देना. ओके, Anamani, fine. And we are going to meet with more stuff in the next class. Till then, you please like and share and subscribe this. Thank you very much. Signing off, Suresh, Faculty of Chemistry.